You're probably listening to this on a quiet evening. Maybe the lights are off, or there's just a faint golden glow left on your desk. Outside the window, the city breathes softly. The clock is still ticking away the seconds, but you don't really mind anymore. And somewhere, through the screen, through your headphones, through tiny invisible waves, I'd like to send you a simple, yet strangely profound question. Is time real? Don't answer just yet. Let the question rest quietly, like a leaf falling onto the surface of water. Don't stir it. We'll sit together, in stillness, and watch how far the ripples reach. You see, time is something everyone knows, but no one truly understands. It's there in every breath, in every sunrise and sunset. We're born, we grow up, we grow old, all to its rhythm. But if someone were to ask, what is time? What shape does it take? Which way does it flow? Or even, is it real at all? We'd probably just smile, shrug, or point to a clock. But a clock doesn't answer. It just repeats an endless cycle. Maybe you're wondering right now, what's the big deal? Time is time. It's what pulls you out of bed in the morning. It's why birthdays come back every year. It's the reason we remember, and also the reason we forget. But what if I told you that some physicists believe time doesn't exist? That in the most fundamental equations of the universe, time doesn't even appear. That on the tiniest scales, where matter stops being and starts maybe being, time doesn't flow, doesn't move, doesn't exist. Then what? I'm not here to keep you awake. Quite the opposite. I hope this journey, like every journey under a starry sky, will help you slow down. We won't rush. We don't need answers. We'll just take a quiet walk together through old ideas and strange possibilities, and try to listen for what holds us here. If time isn't real, you don't need to prepare anything. Just close your eyes. Or not. Just listen. Or not. Let your breath move the way it always does. And if you happen to fall asleep while listening, well, maybe that's a kind of time travel, too. And if you're still here in this moment, hello. I'm so glad you're joining me for this story. A story about time. Something that might be everything, or might be nothing at all. Do you still remember that feeling? That endlessly long afternoon when you were a child, lying in your room, watching the clock hands creep ever so slowly while your heart brimmed with anticipation. Just 5 more minutes until you could go outside and play. Just 5 minutes. But why? Why did those 5 minutes feel like a lifetime? Something strange is going on. Because 5 minutes is always 5 minutes. Whether you're waiting in line at the bank or sitting next to someone you love. But the way we experience those minutes couldn't be more different. When we're waiting, every second scrapes across the skin. When we're happy, an entire afternoon slips by like a gentle breath. And when we're grieving, time can stop altogether. No longer a flowing stream, but a frozen space. Silent, dense, and cold. Strangely, people often say that time is something we can't grasp. Yet we feel it more vividly than almost any other concept. It has no smell, no taste, no specific shape. Yet it's everywhere. In the silver strands in your father's hair, in the cracks at the corner of the wall, in the way someone's gaze has changed after all these years. So what exactly is time? Is it something that exists out there, objective and unchanging, like a river we're all drifting on, no matter what we're doing or thinking? Or is time just a sensation, a flexible concept woven by the human mind, shifting with each moment and each memory? Psychologists call this subjective time. Not clock time, but inner time, the kind we all carry within us, like a personal emotional stopwatch. When you're young, the world feels wide open, like an unmapped field. Everything is new. The first cricket you ever caught, the taste of strawberry ice cream for the first time, the thrill of lighting your first birthday candle. Each day is a series of discoveries, and your brain, still unfamiliar with repetition, records everything like a vivid, high-definition film, full of sounds and emotions. That's why a summer at age 7 can feel as long as an entire adult year. As we grow older, repetition sets in. We settle into familiar routines. The same route to work, the same chair at the same cafe, the same goodnight text sent every evening. These things barely register anymore. And as our memories compress, so does our sense of time. A whole year passes and we can't remember what we had for lunch in March. That's also why falling in love can make time come alive again. Every touch, every glance, every shared laugh, it all gets recorded in high detail. The early days of love often feel long. Not because the clock slows down, but because our minds are capturing everything. Later, as emotions stabilize and encounters become beautiful habits, time begins to rush by again, quietly, like a peaceful sleep. And then there's pain. When we lose something, a person, a chance, a dream, time can suddenly shatter. It doesn't flow anymore. It breaks into fragments of memory, like shards of glass. You might lie motionless through a long afternoon, but inside, feels like you've lived through months. Emotion stretches time like a drumskin pulled tight by sorrow. Science can measure the delay of an atomic clock with exquisite precision, but it can't measure what someone feels after a breakup. Because time isn't only measured in minutes, it's measured in the intensity of awareness. There was an interesting experiment. A person was dropped in free fall from a height of 30 meters, and afterward, asked to estimate how long the fall lasted. Most said it felt 2 to 3 times longer than it really was. Why? Because in moments of danger, the brain speeds up information processing, recording more images, more detail, and we feel like we've been there longer. Time, it turns out, doesn't stretch because of the clock. It stretches because consciousness expands. Another example. You're walking down an unfamiliar street. Everything is new. The signs, the trees, the sounds. Time seems to slow down. But by the 10th time you walk the same route, it all blurs and the journey feels shorter. The brain doesn't store what it already knows, and when memory compresses, so does time. The Japanese have a beautiful concept called mono no aware, the awareness of the impermanence of things. It's precisely because time is fragile, limited, and always slipping away that everything becomes more precious. A breezy afternoon, a wordless gaze, a long hug, these may last just seconds, but can live on forever in memory, as if that memory transcended time and became something outside of it. So what is time, really? Is it the frame we use to hang the things we love and the things we regret? Is it how our minds sort experience? Or is it something objective, existing outside our heads, an invisible stage where the universe performs? Some say time is like a river. Others say it's an illusion. But I think maybe it's like a breath. No one sees it, but we always feel it, especially when it changes, when we rush, when we pause, when we stop breathing. And you know what? Sometimes, the feeling that time has slowed down is just a reminder that you're truly alive. When everything becomes crisp, full, and vivid, maybe that's the moment you're fully present. Not pulled into the past, not worrying about the future. Just here, a single leaf drifting down, a ray of sunlight brushing the curtain, a bird call, a glance, just a few seconds. But sometimes, a few seconds are enough to make you believe that time isn't just a measurement. It's a miracle. If you close your eyes right now and just listen, can you guess what time it is? Not by a clock. Don't look at your phone. Just by feeling. By the dim light outside the window. By the heaviness or alertness of your body. By the sounds around you. Maybe it's the fading noise of a car in the distance. Maybe it's the steady whir of a fan. Maybe it's the tick-tock of a wall clock. Something that, even unnoticed, keeps ticking steadily like the heartbeat of a house. Long before calendars or timekeeping existed, humans lived with time this way, by feeling, by light, by birdsong or the taste of the wind. And then, at some moment, perhaps on a sun-drenched morning by the Nile, someone looked at the shadow of a stone pillar on the ground and wondered, if this shadow keeps shifting in that direction, could we use it to know where the sun is in the sky? That was the birth of the first clock, the sundial. It was simple, no hands, no numbers, just a stick and a shadow. But like all great things, it began with something very small. From that moment, humanity began learning how to measure time. But really, what are we measuring? A shadow moves not because time is flowing, but because Earth is rotating. We're not measuring time, we're measuring change. Similarly, when sand trickles down through an hourglass, we're watching the movement of matter, not time flowing, but gravity pulling grains through a narrow neck. Time, in this view, doesn't exist as an independent entity. It's a name we give to transformation. After the sundial came the water clock, a bowl of water with a tiny hole letting water drip out. The amount of water lost was used to estimate how much time had passed. Ancient Egyptians used it to divide the night into hours. But again, we weren't measuring time but the change in water level. Time has never appeared as an object. It only arrives with movement. Then came Galileo, sitting in a church in Pisa, watching a chandelier sway back and forth in the breeze. With each swing, he noticed the time between the swings was nearly the same whether the arc was wide or narrow. And he thought, maybe we can use this repetitive motion to mark the passage of time. That was the beginning of the pendulum clock. What's beautiful here, for the first time, humans weren't measuring time by external phenomena, like the sun or water, but by a reproducible, mechanical rhythm. From then on, time seemed to step closer to something we might call objective. Yet still, it remained tied to movement. Imagine a sealed room.
No windows.
No sound.
No clock.
You lie in there for a whole day. When you come out, someone asks, how long were you inside? You wouldn't know. Nothing changed. Nothing reminded you. In a space without change, time dissolves. It needs a thing to take form. It lives through motion. In the 20th century, we made a leap forward. The quartz clock. Instead of mechanical parts, it used the oscillations of a quartz crystal under electrical voltage. These vibrations are incredibly stable, tens of thousands per second, making time measurement more accurate than ever. But the essence remained the same. We use oscillation, a form of change, to count. And then came the latest, so far, advancement, the atomic clock. In a cesium-133 atom, when electrons shift between energy levels, they emit electromagnetic waves with a remarkably stable frequency, accurate to within billionths of a second. Based on this, we defined 1 second equals 192,631,770 oscillations of a cesium atom. This is the current international standard. And that's when our original question returns, louder than ever. What are we really measuring when we measure time? We're measuring oscillations, measuring change, measuring rhythm. But does that mean time truly exists? Or is it just a unit we attach to what we call motion? If nothing changed, no life, no death, no wind or drifting clouds, would time still have meaning? Classical physics, Newton's kind, treats time as an absolute backdrop, unaffected by events. But every tool we've ever built to measure time says the opposite. They all need something to happen for time to show itself. A philosopher once said, time is how we distinguish between two different states of the world. In other words, if there's no difference between before and after, there's no reason to believe in time. When you listen to a melody, what lets you feel time isn't the notes. It's the silence between them. Time lives there, in the spacing, the pauses, the length of an echo. In the same way, perhaps time isn't a flow, but the distance between changes. No change, no distance, no time. We use the phrase time passes as if it's a river, but no one's ever seen that river. We only see the leaves moving. Those leaves might be the hands of a clock, a long-lost friend's voice, or a new wrinkle near the corner of your eye. Time, then, isn't the main character, it's the silent stage on which everything else performs. Or maybe it's not even the stage. Maybe it's just how the audience remembers the play. Have you noticed? The more that happens in a day, the longer it feels. But the days that repeat themselves, like during lockdowns, feel shockingly short. Yet strangely, when we look back, we might say, that year flew by, even if each day dragged on. The feeling of time as we live it and as we remember it are two separate realities. And so, even memory, the thing we use to measure the length of a life, blurs the line between real and imagined. Memory isn't faithful. Selects, exaggerates, forgets. And if time only exists in memory, how can it be real? But whether time is real or not, we keep counting. We count school years, birthdays, work hours. We count the minutes to catch a train, and sometimes the seconds to say goodbye to someone leaving. And if anything makes time feel more real than all the physics definitions, maybe it's this: we care about it. Not because it has units, but because it carries something fragile. Each moment that passes is something we can't get back. And maybe that's why we want to measure it, to keep it, to wrap it in numbers. But behind every number still echoes the same old question. What are we really measuring? Imagine you're standing beside a river. The water flows smoothly and steadily beneath your feet. Whether you step into a boat, swim upstream, or simply sit by the shore and listen, the water keeps flowing, with or without your presence. The river doesn't ask your name, doesn't care where you're going. It just flows, quietly, persistently, endlessly. That's how Isaac Newton saw time. In Principia Mathematica, the work that laid the foundation for classical mechanics, Newton wrote, "Absolute, true, and mathematical time of itself, and from its own nature, flows equably without relation to anything external." Time, according to Newton, is real, independently existing, and unaffected by anything happening in the universe. It is a fixed axis, solid and steady like the spine of all things. It flows evenly, needing no one to count it, no one to feel it. It flows even when nothing changes. It flows even in an empty universe. Newton's time is an invisible grid stretched across the cosmos, where everything, planets, apples, bells, moves like little gears in a giant clock. And like a clock, that mechanical world was beautifully designed. Everything could be predicted if you knew the rules and the starting conditions. If you threw a stone, Newton could tell you exactly where it would land. Not just today, but every single time you threw it the same way. In that view, time is the background current of all events. If space is the where of existence, time is the when. And just as a stage remains unchanged no matter how many plays are performed on it, time continues to flow, whether or not anyone is acting. It was persuasive, neat, easy to visualize, and most importantly, extremely effective. For over 200 years, all of modern science and technology was built upon Newton's model. A universe running by clear, predictable rules, unfolding in a single, objective timeline shared by all. So, what made that belief begin to shake? The story begins when astronomers and physicists started noticing that some things didn't add up. When light didn't behave the way it should. When speeds didn't combine like ordinary objects. And especially when clocks, placed in different locations or moving differently, no longer agreed on what time it was. But let's slow down a little. Before the universe starts to rebel, let's take a longer walk through Newton's world. Because it's still beautiful, still calm, still comforting. Like a starry night where you can predict every planet's position with just pencil and paper. In this world, you can draw a graph with space on the horizontal axis and time on the vertical. A point moves along a curve and you've described its entire motion. Everything unfolds within the embrace of absolute time. And in this world, everyone lives in the same now. There is no one ahead or behind. If you and I witness an event, it happens at the same moment for both of us, no matter where we are. Sounds obvious, doesn't it? But soon, you'll see it's not. Because for absolute time to truly exist, we must assume there's some cosmic clock ticking somewhere out there, and that we all must follow it. But no one has ever found such a clock. Newton couldn't prove it. He just felt it had to exist to keep the universe in order. And he accepted that out of faith in the perfect logic of the universe. In a way, Newton's time is like the god of science. Invisible, all-powerful, needing no proof, yet forming the foundation of all motion. But when you dig deeper into the question, how can we know time is passing if nothing changes? You start to see the cracks. Imagine you're floating in space, inside a windowless ship. No engines, no signals. Everything around you is still. There's nothing to use as a reference point. Nothing is changing. How would you know how much time has passed? An hour? A year? The answer is you wouldn't. And if you can't detect time without change, then is time truly real? or just a name we give to change itself? That question hung in the air until a man with wild hair and distant eyes appeared and began to rethink everything. But that's a story for the next chapter. For Newton, time was the first pillar of the universe, and he built an extraordinary structure upon it. No one can deny Newton's math still works today, and his laws still govern everything from rockets to bridges. But under the light of time, every pillar can wear down. Because when we look closer, even closer, at the nature of reality, sometimes what seems foundational turns out to be just a shadow. Newton's time, that calm and absolute river, turned out to be a convenient model, not an eternal truth. And from here, we begin to drift into stranger waters, where the flow is no longer steady, where two people watching the same event might disagree on when it happened, where time can stretch, bend, and sometimes stop. But to get there, we need to meet someone, not a priest, not a poet, but a man working in a Swiss patent office. And he, with a simple but strange idea, would bring Newton's absolute time crashing down like a wall soaked in rain. But that's for later. For now, just close your eyes a moment. Imagine yourself drifting gently down Newton's river. The river doesn't rush, doesn't twist. It simply flows through seasons, through breezes, through every breath. And perhaps, in that moment, you'll understand why the idea, even if later proven wrong, was so incredibly beautiful. Have you ever tried to do something that everyone else thought was crazy? Albert Einstein did. While humanity was peacefully living in a universe where time flowed smoothly like a river, he quietly stepped in and said, without much fanfare, "That river doesn't exist, and if it does, it doesn't flow evenly. It stretches, contracts, bends, and the strangest part, it flows differently for each of us." The universe, once thought to be a static stage with time as a metronome ticking away for all things, suddenly became a soft fabric, shaped by speed and gravity, as if it could feel. Einstein didn't come to physics armed with complex equations from the start. He began with imagination. He imagined riding alongside a beam of light, and he asked, if I were traveling at the same speed as a light beam, and I looked at another beam of light, what would I see? That question, seemingly like a child's, blew a hole through classical physics. Because in Newton's world, light should follow the rules of velocity addition. But in reality, light does not. It always travels at the same speed, no matter if you're standing still, walking, or riding a rocket. And if the speed of light doesn't change, then something else has to change to keep the equations working. And that thing, unbelievably, was time. According to the special theory of relativity, which Einstein published in 1905, time is no longer absolute. It depends on the observer and their speed. The faster you move, the slower time passes for you relative to someone who stays still. It sounds like a philosophical idea, but it's completely real and it's been proven. Imagine a pair of twins. One stays on Earth. The other boards a spaceship that travels close to the speed of light. When the traveler returns, he's younger than his twin. Born at the same time, departed at the same time, but because one moved so fast, time stretched out for him. This isn't just imagination. In 1971, a group of scientists conducted the Haffel-Keating experiment. They took ultra-precise atomic clocks on airplanes, flew them around the world, and then compared them to clocks left on the ground. The result? The clocks on the planes ticked more slowly, just as Einstein had predicted. The delay was tiny, just a few billionths of a second, but it was real. And you might wonder, so what? Look at your phone. When you open a map, the GPS signal is located using satellites orbiting Earth. Each satellite has its own clock, and to get an accurate position, we need to calculate distances based on the time signals are sent and received. If we didn't account for time dilation, GPS would be off by kilometers every day. Your map might show you in the middle of a river when you're actually sitting in a coffee shop. The universe has reminded us. Even if we don't feel time bending in daily life, it really happens, and modern technology depends on acknowledging that. But that's only part of the story. 10 years after special relativity, Einstein proposed something even stranger: general relativity. If the first theory said time slows down when you move fast, The second said, time is also affected by gravity. Where gravity is stronger near a massive planet or a black hole, time passes more slowly than in regions of weaker gravity. It may sound like science fiction, but imagine this. You're standing at the base of a building and your friend is on the rooftop. Because Earth has gravity and you're closer to its center, your time ticks just a little slower than your friend's. This has been confirmed by experiments using atomic clocks placed at different altitudes. The higher you go, the faster time moves, which means if you spend your whole life at the base of a mountain and someone else lives on the summit of Everest, when you meet at age 80, you'll be slightly younger. Just slightly, but still. The closer you are to a source of gravity, the more time stretches. Near a black hole, time almost freezes, at least from the perspective of a distant observer. If you fall into a black hole, someone watching from afar would see you forever suspended at the event horizon, never quite disappearing. But you would feel yourself falling in, and time would continue. This disruption, that time is not the same for everyone, shattered our most basic intuition, the idea of a shared now. Einstein erased the concept of absolute present. In his universe, there is no master clock ticking away for all. Each person is their own clock carrying their own time, and no one can say, "What time is it right now?" without adding, "According to whom?" Someone once asked Einstein, "If time isn't absolute, then what is real?" He smiled and answered, "Only space-time is real." Space-time is how Einstein combined space and time into a single, four-dimensional fabric. In this model, you can't separate when from where. Every event is a point in space-time, and velocity, gravity, mass, they all warp that fabric. Time, then, is no longer a steady river as Newton imagined. It's part of the cosmic fabric, soft and flexible, capable of being stretched, compressed, or bent. You can no longer ask, "When did this happen?" without also asking, "Who is observing?" and "From where?" The world becomes strange, but also more alive. Time is no longer a cold, ticking clock. It becomes a companion with personality, behaving differently depending on where you are, how fast you're going, and what gravity is pulling on you. And while relativity may seem distant, full of equations, the core truth Einstein gave us is surprisingly intimate. No one experiences time the same way. Each of us is living in our own universe with its own rhythm. Your lover might say, "I'll be back in 5 minutes." But if he were traveling close to the speed of light, you might grow old before he returns, still young just as you last saw him. Luckily, none of us are moving that fast, at least not yet. If I gave you a film reel, and you watched a scene where a glass of water tips over, liquid splashes everywhere, and the glass shatters on the floor, you'd instantly know the film is playing forward. But if you saw water flying back into the glass, shards of glass assembling themselves, and the cup rising whole onto the table, you'd laugh without needing an explanation. The film is in reverse. What tells you it's running backward? It's not that the laws of physics forbid it. On paper, all the fundamental equations of physics, from Newton's mechanics to Maxwell's electromagnetism, even the Schrödinger equation in quantum mechanics, can run both ways in time. If you swap t with t in the equations, they still hold true. Particles still move. Waves still propagate. Everything still works. So why, in real life, does time seem to flow in just one direction? Why do we always remember the past but never remember the future? The answer, or at least the biggest clue, lies in a single word: entropy. Entropy is a concept from thermodynamics that describes the level of disorder in a system. But don't rush to the equations. Just picture this. You clean out your closet. Every shirt, every sock folded neatly, everything in order. Then life happens. 1 hectic day, 2 weeks of not touching it, 3 frantic searches for a sweater, and the closet becomes a mess. That's entropy. It's the natural tendency for things to go from order to disorder. Not because you tried to mess it up, but because there are far more ways to be messy than to be tidy. An egg has a clear structure: shell, whites, yolk, delicately arranged. When it hits the floor, all you have to do is watch it breaks. Not because any law demands it to break, but because broken is far more likely than whole. And the second law of thermodynamics confirms it. In a closed system, entropy always tends to increase over time. That's the arrow of time, something equations don't have, but our experiences do. In an expanding universe, where heat disperses and gas particles collide randomly, every system moves from less probable, ordered states to more probable, disordered ones. And we, living inside that flow, feel the direction of disorder and call it time. Imagine a sealed box, gas filling the left half, the right side empty. You remove the divider. Slowly, the gas spreads evenly. Nothing surprising. But if you saw gas spontaneously gather back into one side, like someone sucking time backward, that would feel impossible. Not because it's theoretically forbidden, but because the probability is nearly zero. Everything in the universe, from stars and planets to the feelings in your chest, is shifting from order, concentrated energy, high structure, to disorder, diffused energy, lost information. And the arrow of time is simply the direction in which entropy grows. You can't remember the future not because it hasn't happened, but because it hasn't left any trace. The past, on the other hand, is full of marks. Light burned onto your retina, memories stored in your brain, scratches on the glass, dust on an old photo. But if that's true, then time isn't a thing that flows, it's just the direction of memory, of disorder, of trace. And that is worth pondering. Someone once said, memory is the footprint time leaves behind. But what if no one left any footprints? What if there was no disorder to distinguish yesterday from today? What if everything just repeated, perfectly, indistinguishably? Then maybe time wouldn't show up at all. Here's something curious. Quantum mechanics, which allows time reversal in its equations, still presents something deeply one way. Wave function collapse or measurement. When you observe a quantum system, it's forced to pick a specific state, and you can't undo that measurement. Once you've seen the cat, alive or dead, you can't go back to the moment it was both. Another hint that, in the human world, something only moves forward. You might ask, then can time ever stop? The answer is yes, at least as a feeling, in states of total flow, deep meditation, an accident, a coma, or a moment of overwhelming joy. People often say they stopped sensing time. No fast, no slow, no later, just complete stillness. But then, entropy begins again. The clock ticks, dust floats, traces are left, and time walks on. The paradox is, life only exists because it fights entropy. Our bodies burn energy constantly to maintain temporary order, to keep cells intact, hearts beating, memories from falling apart. When life stops, entropy wins. Everything returns to randomness. No more structure, no more names, no more time. So, maybe we only feel time moving one way because we're pushing against the chaos. And when we stop resisting, when we surrender, time dissolves too. That question still hangs there, like a falling leaf. But you know what? As long as you're still remembering, a face, an afternoon, an old song, then time is still moving in one direction. And that direction is the human one. Maybe the universe doesn't need time, but we do. Because we are creatures of loss, of change, of memory. And when you look at a messy room, you'll know, this is the present. And cleaning it up is how you remember you're still alive. Have you ever stared at the clock's hands and felt like they weren't moving? You fix your gaze, count your heartbeat, try to detect motion. But the more intently you look, the more it feels like time has come to a stop. Strangely enough, quantum physics suggests you might be right. Because in the bizarre world of subatomic particles, where everything is fuzzy, probabilistic, and uncertain, time is no longer a fixed axis, no longer a steady flow. In fact, in some of the universe's most fundamental equations, time completely disappears. To understand this, let's go back to one of the most famous equations in modern physics, the Schrödinger equation. This is the equation that describes how a quantum state evolves over time. In other words, If you know the state of a particle right now and you know t time, you can predict the probabilities of different future states. It's very much like Newtonian mechanics, but instead of certainty, you get probabilities. Time here still exists. It's the variable t. But physics wanted something bigger, an equation for the entire universe. Not just a particle, not just a small system, but everything, you, me, galaxies, even space and time itself. And in that pursuit, another equation emerged. One with a name that's almost poetic. The Wheeler-DeWitt equation. The most surprising thing? There's no t, no time variable, no before and after.
No ticking. No flowing.
Just a static equation, as if the universe doesn't change, doesn't move, doesn't live. It simply exists. Sounds like a paradox. We live in a world of constant motion. Clocks tick, hearts beat, day follows day. So how could a static equation possibly describe it all? The answer, according to many modern physicists and philosophers, is this: time is not fundamental. It's an illusion that arises when we observe only a tiny slice of the universe. Like watching a movie. Each frame is still, but when played in sequence, you feel the motion. Julian Barber, a strong proponent of this idea, says, the universe doesn't actually flow. Instead, it's a collection of infinite moments. He calls them nows, each now being a complete configuration of the universe. They don't line up. They don't replace each other. They don't pass. They just exist. What we call the passage of time is merely the illusion of consciousness, jumping from one now to another, remembering what seems to be before. It's like standing in an infinite library. Each book is a moment. You open one and find yourself sitting and reading, and recall that, before this, you had breakfast. But breakfast didn't come before. It's just another book, lying there, existing. You just happen to be in this one, and this one contains a memory of that one. Our sense of time, Barber says, is the result of memory and informational structure. Nothing flows. Everything is there in a still but infinite portrait. Some interpretations go even further. The many worlds interpretation suggests that every time you make a decision, the universe splits. One version of you picks A, another version picks B, and both still exist in parallel worlds. In this view, the future doesn't pre-exist, nor does it flow from the past. Instead, it's a collection of all possibilities, and you, with each choice, simply slide into another branch. But each branch is still a separate moment, not requiring a timeline to exist. In other words, the universe doesn't need time to be. Only we need time to understand. There's a famous moment in modern physics called the problem of time. When you try to merge general relativity, where space-time is a flexible fabric, with quantum mechanics, where truth is encoded in probabilities, time disappears. Not because it's wrong, but because it's no longer necessary. It's like the horizon. You need it to navigate while standing on the ground. But from high above, you realize the horizon is just an illusion of perspective. Still beautiful, still real as experience, but not fundamental. It's deeply ironic that the further we delve into the structure of reality, the more time, the backbone of our existence, fades into a shadow, a byproduct, an emergent phenomenon, like seeing leaves rustle and thinking you've seen the wind. But what is wind without the leaves? And just like that, what is time without change? Or more precisely, time is how we perceive change. But change, in some interpretations of quantum physics, isn't real either. There are only probabilities, superpositions of states, and it's your act of observing, of measuring, that collapses something into reality. And the more you try to measure, time seems to slip away. There's a strange silence in the Wheeler-DeWitt equation. It doesn't tell a story of before and after. It doesn't care about the present. It has no ticking. It's like a frozen painting. And in that painting, everything that has happened, is happening, and will happen all coexist. Simultaneously, indistinguishably. The universe is like a photograph of infinite exposure. And we, in our brief spark of awareness, call that time. You might ask, if time isn't fundamental, then what is this feeling of aging? of life and death, of growing up? The answer is, that feeling is real. But like hunger, like pain, it belongs to consciousness, not the structure of the universe. And that doesn't make it any less important. On the contrary, it means that consciousness is where time is created. We remember, we anticipate, we wait, we regret. All of that is time, not something out there drifting between galaxies, but right here inside us. Julian Barber once said, "The universe does not change. We don't move through time. Each state exists, independently, completely, and time is merely the illusion of memory." Maybe he's right, maybe he's not, but perhaps it doesn't matter, because right now, as you read these words, you're touching a specific moment in that imagined flow. You're sitting in one now, which may contain memories of many other nows, and that this feeling of living inside a moment that remembers is perhaps the deepest definition of time a human being can ever grasp.
No alarm clock, no reminders, no ringing bells.
Yet every morning, when the first light slips through the curtains, you open your eyes. No one wakes you, but your body knows. You feel hungry around noon, tired by early evening, alert when the sun rises. Your eyelids start to droop after 10 p.m. Every day, whether you live in a quiet countryside or a neon-lit city, some hidden rhythm is quietly guiding you from within. Not everyone notices, but the human body is a symphony of time. Every cell, every hormone, every life function, from your heartbeat to feeling sleepy at 10:30 p.m., follows an internal timekeeping system called the biological clock. And it's not just one clock. It's a network of tiny clocks, embedded in each organ, each cell, all ticking in harmony with a larger rhythm we call the 24-hour cycle, or the circadian rhythm. Imagine your body as a vast city. Each organ is a district. The brain is the administrative center, the liver is the chemical processing plant, the heart is the main pumping station, and the gut is the food distribution hub. For this city to run smoothly, each district must work at the right time. If the plant starts processing when the distribution center isn't ready, chaos. If the heart pumps vigorously while you're in deep sleep, it wastes energy. To keep everything in sync, your body relies on a master clock located deep in the brain, in the hypothalamus, in a cluster of cells called the SCN, suprachiasmatic nucleus. The SCN is the conductor of this biological symphony. It orchestrates your sleep-wake cycle, blood pressure, body temperature, and hormone release, all in roughly 24-hour cycles. The fascinating part? The SCN doesn't actually know what time it is. It has to be reset daily by light, the most powerful signal your body uses to determine whether it's day or night. When light hits your eyes, signals are sent to the SCN, which then triggers or suppresses hormones that adjust your circadian rhythm. One of the most important hormones is melatonin, often called the hormone of darkness. At night, when light fades, the SCN allows the pineal gland to release melatonin, making you feel sleepy, lowering your body temperature, and preparing you for deep sleep. In contrast, when the sun rises or when you turn on bright lights at 1 a.m., light signals tell your body it's time to wake, and melatonin production is suppressed. The feeling of tiredness vanishes, even if your biological clock isn't quite ready. And that's why you get jet lag. When you fly from New York to Tokyo, the sudden time shift scrambles your entire system. The SCN still thinks it's daytime, while outside it's pitch black. Melatonin doesn't know whether to kick in or stay back. The liver's unsure when to detox. The gut doesn't know when to feel hungry. It takes days for your biological clock to recalibrate by syncing to the new light cues. Jet lag isn't just fatigue. It's a misalignment between you and the world. And in our modern world, with artificial lights, night shifts, glowing screens around the clock, many people are living in a state of chronic jet lag. Staying up late, sleeping in, hormones out of sync, moods swinging, memory fading. We think we control time, but in reality, we're fighting against the deepest rhythms of ourselves. But if you slow down, breathe deeply, turn off the lights on time, open the curtains in the morning, and go to bed before midnight, something magical happens. Your body adjusts itself. You start waking up at the same time every day, even without an alarm. Hunger arrives on schedule. Your sleep deepens. Your mood lightens. That's not luck. That's your internal time coming back into sync with the natural rhythm of Earth. And here's the fascinating part. The SCN isn't the only one with a clock. Research shows that your liver, heart, kidneys, lungs, and gut all have their own peripheral clocks. These also run on 24-hour cycles and are influenced not just by light, but by meal timing, physical activity, and sleep. If you eat late at night, your liver clock gets confused. If you work out too late, your heart falls out of rhythm. If your sleep is irregular, all your clocks fall out of sync. And when your body lives in a chorus gone offbeat, you feel exhausted, unfocused, irritable, sleepless, prone to weight gain, and less resistant to illness. At that point, time is no longer just a concept. It becomes something you can feel in your flesh and blood. Perhaps the strangest thing about biological time is it doesn't need your awareness. Newborn babies, who have no idea what a clock is, still develop a sleep-wake rhythm shaped by light. Plants with no brains still know when to open leaves or close buds. Single-celled algae maintain a 24-hour rhythm even in total darkness for days. It seems that time has been woven into the fabric of living things, like a background melody that life automatically plays. And that's what makes us truly remarkable. We don't just live in time. We are born with time inside us. A clock that ticks through hormones, through cellular voltage, through neural impulses. A clock that makes no sound, yet orchestrates every movement of life. Time, in the end, isn't just something out there. It's a quiet melody playing right now, inside you. Imagine you're sitting in a clinic, waiting for your MRI results. You glance at the clock. Only 3 minutes have passed, but it feels like half an hour. Now think back to the last time you went on a trip with your best friend, laughing and chatting all afternoon. Before you knew it, the sun had set. Same clock, same unit of time, but the experience, completely different. Why is that? Because time for the brain is not a steady flow. It doesn't tick by like a metronome. It stretches, bends, twists, and warps, just like our emotions. For centuries, philosophy has wrestled with a single question. Is time something that exists outside of us, or just a way we perceive change? Modern science doesn't give a definitive answer, but psychology shows this. The human brain doesn't measure time like a clock. It reconstructs time from memory, attention, emotion, and experience. Let's start with the most familiar question. Why does time drag when we're waiting? When you're waiting for a bus, every second feels stretched out. Every minute feels endless. But when you're completely absorbed in something exciting, composing music, painting, playing a game, you enter a state called flow, and your sense of time disappears. That's because the brain doesn't have a built-in mechanical clock. It estimates time based on how much information it processes. When you wait in anxiety, you notice everything: the ticking clock, flickering lights, people shifting around you. Your brain processes a lot of input, so time feels slow. On the other hand, when you're in flow, you're hyper-focused on a single task. You tune out everything non-essential. The brain goes into energy-saving mode, and time seems to fly. Another strange phenomenon is time expansion. People who've been in serious accidents often say that time slowed down. They saw everything in slow motion. The car spinning, glass shattering, their body flying out of the seat. What's happening here? In extreme moments, the brain switches into high-speed recording mode. Stress hormones like adrenaline surge. Your eyes widen, hearing sharpens. The brain records every detail. Later, when recalling the event, the sheer volume of information makes it feel like it lasted longer, even though it was only a few seconds. But time perception isn't just shaped by stress. It's shaped by age too. You've probably heard or said something like, "The older I get, the faster time flies." Why? As children, everything is new. First day of school, first time reading, First ice cream, beach trip, or argument with a friend. Each new experience becomes a vivid memory. As we grow older, life becomes repetitive: work, lunch, emails, scrolling. Fewer memorable landmarks each day. So when we look back, the brain finds nothing worth noting and concludes time passed quickly. We don't remember a month of routine work, but we vividly remember that trip to Dilat in 2016 or our high school graduation. The richer the memory, the longer the time feels. This is called the memory density effect. Our sense of time is reconstructed not by minutes passed, but by how many meaningful experiences we had. So if you want to slow down time, try living more novel experiences. Learn something new. Visit a place you've never been. Make a memory worth keeping. Looking back, that stretch of time will feel longer, fuller, more real. There's another odd psychological effect. The trip home feels shorter. Have you noticed? On the way to a new destination, the journey feels long. Every turn, building, and sign is unfamiliar. Your brain is recording constantly, so time feels stretched. But on the way back, it's all familiar. You pay less attention. The brain processes less. And so time feels shorter. It's not the distance that changed. It's the experience of it. All of this leads to one conclusion. Time doesn't just pass around us. It passes through us. It's shaped by attention, memory, emotion, and deeply human things like boredom, joy, anxiety, and passion. When you're in love, you want time to slow down. When you're heartbroken, every minute is agony. When you're lost in a sunny afternoon laughing with friends, you forget time exists at all. And in those moments, you realize time doesn't have a fixed speed. It runs on your heart. There's a fascinating theory. The brain doesn't measure time, it simulates it like an internal movie. Each memory is a frame. Emotions add color filters. Attention is the camera. And you, the observer, are also the director of your own time film. No two people live the same minute the same way. A 7-year-old waiting for their mom after a meeting feels 10 minutes as endless. Two lovers sitting in the rain feel 1 hour as a blink. Everyone is a director of time, but you can learn to direct it more skillfully. Not to control time, but to live each moment more deeply. When you pay attention, open your heart, enter flow, create memories, live fully, you stretch time in ways no space-time physics can match. But when you drift, go on autopilot, repeat the same day, you let time dissolve into smoke. So maybe living slowly doesn't mean slowing down in the physical sense. It means living deeply so that each moment becomes rich. Time is a river, yes, but our brain doesn't just watch it pass. We reach in, stir it, shape it, and redraw its flow in our own way. And that's why humans aren't just victims of time. We are artists, coloring this invisible current with memory, emotion, love, and even waiting. Have you ever dreamed of going back in time? Just to tell yourself one thing, just to stop a mistake, just to see someone you lost, even for a second? That dream is as old as regret itself. From Greek mythology to modern novels, from H.G. Wells' Time Machine to Back to the Future, humans have spent centuries playing with the idea of time travel. But what about physics? Could there actually be, somewhere in the hidden folds of space-time, a secret doorway that leads us back to the past or forward into the future? The answer, as with all grand questions, is maybe and maybe not. Let's start with the part that's closer to reality. Traveling into the future sounds like science fiction, but strangely enough, Einstein proved it's entirely possible. Not with a shiny silver machine, but with the stretchy nature of time itself. In special relativity, time slows down when you move close to the speed of light. That means, if you travel around the Earth at nearly 300,000 kilometers per second, time will pass more slowly for you. You could go on a deep space journey, then come back, only to find everyone on Earth has aged decades, while for you only a few months have passed. This isn't just theory. It's been confirmed by experiments. Astronauts, jet planes, even GPS systems all must account for time differences caused by motion and gravity. The closer you are to something massive or the faster you move, the slower time passes. An atomic clock on the ground floor runs slightly slower than the same clock on the 20th floor, which means we are already time travelers just by a few billionths of a second each day. But what about the other direction? Can we go back in time? That question, seemingly simple, has puzzled physicists for over a century. The issue isn't just technology. It's paradox. Suppose you go back to 1963 and stop your father from meeting your mother. Then you were never born. But if you were never born, who went back to stop them? That's the grandfather paradox, the classic time travel mindbender. It's not just confusing, it threatens the consistency of the entire universe. An event in the future can't change the cause that led to it. Physics doesn't like circles of cause and effect. One way scientists have tried to rescue time travel is through wormholes. These are hypothetical bridges connecting 2 points in space-time, like the ends of a straw linking distant places. If you move one end at near light speed, or place it near a black hole, the 2 ends would shift in time relative to each other. The theory says, if you enter the slower end, you might come out in the past of the other. Simple? Not even close. Wormholes, if they exist, would be wildly unstable. Any interaction, light, matter, could collapse them. To keep one open, we'd need something called exotic matter, stuff with negative energy, something no one's ever created. Even if you did make a wormhole and stabilized it, you'd still run into paradoxes. So some physicists offer an intriguing escape, the Novikov self-consistency principle. It says, if time travel happens, it can't create paradoxes. Whatever you do in the past was already part of the timeline. You can't change the past. You're simply participating in it, like a side character in a play that's already written. You might go back and save a child from an accident, but perhaps that child is you. Perfect loop.
No contradiction.
But no change either. Another way to dodge paradoxes. The many worlds theory. According to this view, every action splits the universe into branches. If you go back and kill Hitler, you don't change the original universe, you just create a new branch where Hitler never existed. You continue living there, but your own past remains untouched. In this way of thinking, every possibility happens somewhere. You're just one stream in a vast ocean of parallel universes. All of this leads to a strange model of the cosmos, the block universe. In this view, past, present, and future all exist equally. Nothing flows. There's no special now. We're simply experiencing one slice of a four-dimensional block that's already set. Like a film reel. Every frame is there, you're just looking at one. The sense of now is just that, a sense. And if that's true, then time travel is just moving from one frame to another. It's hard to say which of these is real. Physics still lacks a unified theory strong enough to give a final answer. But what's certain is, time is not simple. It's not just a straight, one-way stream. It's a complex structure, full of logical cracks, imaginative windows, and paths we may never walk. But who knows? One day, humans might build a machine that takes us back to 3:45 p.m. yesterday, or leap forward to April 2150 to watch a sunrise on another planet, or simply return to one perfect moment in life to live it once again. And if that never happens in physics, it still happens. Every time we close our eyes, recall a memory, and feel it alive, vivid, present, as if time had turned back. Time travel, perhaps, was never physics first. It was psychology, emotion, nostalgia. And because of that, perhaps we've always been time travelers, simply by remembering a person, a scent, a laugh. There's a question that seems simple, but no one can fully answer it. What happens to time when we die? Do the dead still experience time? Or does time, at least what we call time, die with us? Maybe to understand, we have to step back and ask, where does time begin? Not with the Big Bang, not with a clock, but with awareness. From the moment we're born, we have no concept of time. Only hunger, cold, and a mother's arms. Then we grow up. We notice day and night. We begin to understand before and after. We realize that everything changes. That childhood slips away, and gray hair waits ahead. And then, someday, without knowing exactly when, we begin counting down. Death has long been tied to the feeling that time stops. The dead don't wake up. They no longer feel a tomorrow. They don't experience next week. They have no plans. Every intention slips out of the current. But for those left behind, time keeps moving. Meals still need cooking. The car still needs gas. Work still needs doing. And that afternoon, when you walk past the empty chair, you suddenly realize that person is no longer in time. They don't move forward with you, but they're not exactly left behind either. They seem to have fallen out of the stream, and somewhere, forever begins. To many religions, death is a gateway to another kind of time. Some call it reincarnation, the turning of life's wheel. Some call it heaven, where time is no more. Some speak of other realms where past, present, and future blend into one. But whatever the tradition, one theme echoes. Death breaks the familiar structure of time. It erases what comes next, leaving only forever. Physics has a very different and very cold view. According to the block universe model, past, present, and future all already exist. The person you love is still alive, somewhere in a slice of space-time. That handshake in 2005 is still happening, but you are no longer there to feel it. In this view, death is not disappearance, but you walk through one room and into another. Others are still standing in the previous room. Everyone has a personal timeline. Death is simply the end of your subjective experience. The universe remains untouched, needing no witness, no continuation. But it's hard to accept that view, because we are not theories. We are living people. We feel the emptiness left behind by those who've died. An emptiness that no clock can measure, yet stretches endlessly in the heart. Psychology shows something strange. When we lose someone, our sense of time changes. Some people feel like time freezes. There's no more Monday or weekend, just a hazy, nameless blur. Others feel time speeds up. A month vanishes in a blink. A year passes without being felt at all. Because grief scrambles everything. Your biological clock, your emotional clock, your memory clock. No more meals at the usual hour. No more texts at the usual time. You didn't just lose the person. You lost all the time that used to belong to them. And death, for those who remain, isn't just absence. It's the moment time tears open. But within that tear, something else begins. Forever. You'll never forget them. Their final words. That smile from years ago. Their favorite dish. The small things no longer happening freeze in place. They don't pass. They don't fade. They don't change. Forever isn't something in the far future. It's slices of the past that will never be erased. And in that way, the person still exists. Not in time, but in the archive of feeling. Someone once asked, if death is the end, what's the point of life? The answer doesn't come from philosophy, but from the simplest things. Have you ever cried remembering someone? Smiled when hearing their favorite song? Seen a familiar place and thought, I wish you were here. That's proof they're still in you. And somehow, time is still reaching back to connect. Death may end a life, but it doesn't end the flow of impact. It can't erase what you felt, remembered, or shared. And as long as you keep sharing their story, time still flows through them. So maybe death isn't time's enemy. Maybe it's what gives time its meaning. Because without limits, we wouldn't value anything. Without a last time, we wouldn't treasure this time. When we realize a moment can never repeat, that moment becomes eternal. And maybe in the vast stream of time, the most precious gift isn't immortality, but living with limits, so that every minute is worth living. So, does time really exist? That question, simple as glancing out the window at dusk, touches the deepest layers of human understanding and feeling. After all the pages we've read, the slips of gravity, the theoretical wormholes, the cracks in our psyche, the silent rhythms pulsing through our bodies, we somehow return to the very first question. the one echoing from the core of awareness itself. Time, the thing we're living through. Is it real? Some say time is only the present. The past is gone. The future hasn't arrived. And this now is all that truly exists. Everything else is memory, anticipation, a blurry illusion in the mind. But when we close our eyes and remember childhood, it feels like we're there again. When we worry about what hasn't happened, our heart races as if it's already real. Can we truly say these moments don't exist just because they fall outside of right now? Others believe that the past, present, and future all exist equally, as if every moment of our lives, the first time we loved, the first time we fell, the morning that hasn't yet come, are all laid out on a map already drawn. We're just passengers moving through each scene already built. Time doesn't flow. It simply appears in the order we experience it. Maybe, in that sense, every hug, every word, every farewell evening we've ever lived still exists somewhere in the four-dimensional structure of the universe. We just can't go back to see them anymore. Still, some disagree. They say time is like a block growing 1 second at a time. Every breath, every memory, every choice. You're placing a new brick on the wall of your personal timeline. Everything that has happened remains there, fully shaped. What lies ahead? Still undefined, still waiting for you to arrive and give it form. In this view, time isn't a finished recording but a living draft. One where you are both author and main character. But maybe all of these are just 3 ways we try to explain something we can't actually grasp. Because in the end, time, for us humans, has never just been a unit to measure or a neutral physical flow. Time is something we tell. It's what gives stories a beginning, a climax, an end. It's the invisible thread that ties together memory, change, everything that turns a life into a life. Time isn't something outside of us. It lives in how we live, how we remember, how we feel. Time isn't a number. It's not the ticking of a clock. Not minutes or seconds. It's a feeling pieced together from the look a mother gives her child on the first day of school, the first smile from a stranger who becomes someone familiar, the late-night hand squeeze in a hospital hallway. It's the rain from that one day. It's the sunlight through the summer window when you were 12. It's the backward glance in the moment you realize you'll never see someone again. That is time. And if those things aren't real, then what is? So maybe time doesn't exist as some independent entity. It's not just waiting there for us to enter. It forms when we pass through something and then look back. Time is the shadow that meaning casts. When we don't feel, don't remember, don't hurt, don't love, time vanishes. But the moment something matters, it freezes, it shows up, it stretches endlessly inside us. And now, after everything, after we've walked together through childhood, through science, through paradoxes, biological detours, emotional cliffs, there's only one question I leave you with. Not to answer, but to keep as a quiet companion. For every time you glance at a clock, sigh it's flying by, or flip through an old photo and feel something stir in your chest, what time is it? Where you are right now.